Okay, this is week 6 chemistry CA. Since it's a bit late, I'm gonna speed up the recording. I'm not gonna explain too much. When we have these in the periodic or final, I'll go into detail explaining it a bit more. Hydrocarbons are organic compounds. Which of the following are the only atoms present in a hydrocarbon? Hydrocarbons are made up of only carbon and hydrogen. In the exam, what are they going to do? They're not going to tell you what's present in hydrocarbons. No, they're going to tell you which of the following are hydrocarbons. And they might give you an example like this. Why is this going to be wrong? Because it has oxygen, okay? So, it can only have carbon and hydrogen. So anything that only has carbon and hydrogen is correct, okay? Question 2. Which of the following is true about the crystal lattice of a molecular substance in the solid state? Every compound is, if you zoom in, is kind of made out of crystal lattices, okay? Because they all formed a structure together as a solid, right? They're all a crystal. Solids are pretty much crystals. Whether you're an ionic compound or a molecular compound, you're going to have a crystal. What differs the crystal is that for ionic compounds, you're going to have crystal lattices that are made out of ions, right? But in a molecular compound or a molecular substance, the crystal is going to be made out of molecules. That's it. Question 3. Which of the following is true about a lattice structure? Obviously, it's 3D, right? 3 dimensions, because you have 1, 2, it's a cube. Like you can think of it like this, right? Over here, like this. Then you go up over here, and you go up over here, and it goes like this. This goes like this. This goes like this, and it comes down over here, goes here, goes here. And these are connected. So you kind of get what I mean. It's a 3D, right? It designates the position of molecules in a solid crystalline, obviously, right? It shows the position of the molecules. It also designates the position of atoms in an atomic solid crystalline and designates the position of ions in ionic solid crystalline. Does it designate the position of components in an amorphous solid? No, we don't even know what an amorphous solid is, okay? Solid crystals, you can have 3. You can have molecular, okay? You can have ionic, or you can have atomic, okay? Atomic is like network solids, okay? Ionic, made out of ions, okay? Atomic also can be either network solids or metallic, okay? And molecular solids is made out of a molecule, right? Molecules, non-metals only. This is metal, non-metal. This is made out of either metallic or network solids. What can form network solids? Carbon and I think it was silicon, okay? Silicon dioxide. These two are the network solids we need to know for our level. Metallic solids are any metals. You guys know the metals are any element on the left side of the periodic table. That's all you have to know, okay? There are properties for each one. Metallic solid has delocalized electrons, can conduct electricity. You know what? I'm going to open notes for this. Wait. Okay, so I advise to go over the notes if you want. Basically, there are 2 types of bonding. There's inter and intra. Intermolecular forces are in between, and like inside the atom, right? Between the molecules, right? So if you have one water here to bind to another water, it's like this, okay? Intramolecular forces are within the molecule. So between NH2O, between the H and O and the other H, that's actually intra. That's whatever, that's about. You can read this, whatever. Okay, here are the bonds, okay, in a crystal. In metals, it's what we call metallic bond, right? And also van der Waals forces. But metallic bonds is the most important one. Metallic bond is for metals, okay? Ionic compound is obviously ionic bond between metal and non-metal. Non-metals, okay, they can be noble gas structures, okay, these are noble gas structures, they are monoatomic, okay, or polyatomic like S8, P4Cl2, O2, and 2H2. These are all van der Waals, okay, so you have sulfur bonded to another sulfur. This is what we call a van der Waals. What VDW stands for is van der Waals, and it's actually just very weak interactions, okay? You don't need to know much about it other than it's very weak interactions, okay? Then carbon in diamond or graphite, or Si and SiO2, we said it forms a network solid and gets you covalent bond, right? They're covalently bonded together. Any molecular compound is van der Waals. So what do you need to know? Everything has van der Waals bonds, everything, okay? Except ionic compounds are formed by ionic bonds, and metals are formed by metallic bonds. I'm going to go in detail, I'm going to explain just a bit, okay? These are the solids, okay? These are the type of solids, ionic solids. The ions are the lattice points, okay? They're made of ions. Molecular solids are discrete molecules on the lattice points. Atomic solids they're pure elements like مثلا these helium, neon, krypton. Metallic solids are only metals like lithium, potassium, magnesium, whatever. Network solids, carbon, like we said, carbon and diamond or graphite, or silicon and whatever. And group 8A are the noble gas. If this is the noble gas, then I don't know what's atomic solids. Okay, you can read over this, whatever. Okay, what is an ionic bond? You need to know this. It's a strong electrostatic force of attraction. Okay, why? Because you have positive ions and negative ions. What happens when you have positive and negative? You get electrostatic force. That's what it means, electric force. Okay, an ionic compound forms. Okay, this is an ionic compound. You need to memorize these. Okay, read over this, pause and read. Okay, hard. Obviously, they're hard. Okay, why? Because it's the arrangement, right? They have high melting point, boiling point because they're strong, right? Usually soluble in water because it's made out of ions, right? Obviously, any positive and negative ions. You know, the lattice is pattern of positive, negative, negative, positive, negative, positive, 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 negative. You know, like they're all bounded together. They do not conduct electricity, but you need to know that when they're molten or aqueous, they can conduct, right? When you dissolve, they can conduct. Because when solid, ions are not free, but when molten or aqueous, ions are free. Brittle, why brittle? Because of the structure. You can see here. You can push the ions against each other. Whatever, Okay, covalent crystals. A covalent bond is formed when a pair of electrons is shared, right? They are gases or volatile liquids or low melting point salts. So they are gases or volatile liquids or low melting point salts. Why? Because they're made of simple molecules and intermolecular forces are very weak. This is very important. Anytime they ask you, written, computer, anything, why is the melting point low? Why is the boiling point low? Why is it a volatile liquid? Why is it a gas at very low temperature? Why is it weak in general? Anything that has to do with weakness is because the forces making the compound are weak. You say intermolecular forces are very weak. Okay, and then you say not much energy is needed. Okay, and I said I want to explain, but I'm explaining. Insoluble in water but soluble in organic solvents, covalent crystals, do not conduct electricity. Right, they do not conduct electricity. Why? Because they have no free electrons. Okay, metallic crystals. Okay, the metallic bonds. Metallic bond is an electrostatic force of attraction between the positive ions in a giant metallic lattice and a delocalized sea of electrons. All these metal ions will lose electrons. Okay, this is the definition of metallic bonds. All these metals, lose electrons. So when they lose electrons, they become positively charged. So the other positively charged metal is going to get attracted to this electron. They're all going to come together and get attracted to all these sea of electrons, the delocalized sea of electrons. The structure of a typical metal, it's formed of positively charged ions arranged in a lattice structure surrounded by electrons. I'm going a bit fast, but bear with me. You can read all of this, why. Read if you want. I'm not going to skip it fast. Network solids, okay, giant covalent structures shown by some elements. The basic unit is an atom. It's either carbon for diamond and graphite, or for silicon dioxide, whatever, it's a molecule. Okay, so the basic structure can be an atom, as it's here in diamond graphite, and for giant molecular structure, the basic unit is a molecule. But it's actually an atom, but we consider it molecule like silicon dioxide. Okay. This is what you need. This is very important. Allotropy. Allotropy means when two or more elements exist in the same physical state. Two or more forms of an element exist in the same physical state. Allotropes of carbon are diamond, graphite, and buckminsterolene. They're all carbon. This is all carbon, carbon, carbon. But they have different structures. They're still solids, but they have different structures. Okay. So like, look, diamond looks like this. You need to know it's a tetrahedral. Okay, the shape. What's a tetrahedral? It's when you're bonded to 4. Okay, let me change my color to red. When you're bonded to 4, it's called a tetrahedral. Okay, when you connect them, you see how it looks like a tetrahedral. You need to know that. You also need to know, I think they mentioned it here. Do they say the angle? They don't. Okay, you can read over this. There's no electric conductivity because there's no free moving electrons. However, for graphite, this is how it looks. You need to know that they're bonded by covalent bonds. Okay, and both surfaces are bonded by van der Waals, which are weak forces of attraction. That's why it's soft and slippery, because of the weak forces of attraction. And since each carbon is only bonded to 3 instead of 4, like in diamond, you're gonna have one free electron that's gonna cause some electric conductivity. Okay, and then high melting point, whatever. Read over this if you want, whatever. خلاص, I'm gonna do silicon dioxide and خلاص. Silicon dioxide again is a network solid. You need to know that each silicon is bonded to 4 oxygen. Okay, the red is oxygen. It's also tetrahedral. Look, 1, 2, 3, 4, connect. You see how we got this tetrahedral? Each silicon atom is bonded to 4 oxygen, and every oxygen is bonded to 2 silicon, right? You can read over this. Obviously, no electroconductivity. It's high melting point and very hard, okay? The rest is all questions. هيك نكون شرحت كل chapter 9 in 7 minutes. Let's continue, okay? Question 4. Question 4. Which of the following are organic compounds? An organic compound is any carbon-containing compound except exceptions. What are the exceptions? Any oxide of carbon, any carbonate, and CO3, and hydrogen carbonate, so CO3 to HCO3. So anything with CO, any C with oxygen, any CO3 carbonates, and any HCO3. Okay, these are all not organic compounds. These are the exceptions. The rest are all carbon-containing compounds. That means they're organic. Okay. Which of the following statements explains why diamond is hard and does not conduct electricity? Hard. Why is it hard? Because the atoms are strongly and covalently bonded together. Does not conduct electricity. That means there's no free electrons. To conduct electricity, there has to be electrons. Okay. So it has one free electron. No. Its layers are bonded with weak van der Waals. No. Its layers can slide past each other when a force is applied. No. That if they can slide past each other, then it's not hard. Question 6. Which of the following can produce carbon dioxide gas? Okay, this is just in general, general knowledge. Obviously, respiration. When you breathe out, you release carbon dioxide gas, and cellular respiration that occurs in the cells of your body. When calcium carbonate reacts with dilute hydrochloric acid, remember acid plus carbonate gets you carbon dioxide gas, right? We remember this. And when methane burns in air. You need to know these, okay? They're part of topic 4, carbon. Okay, if you want to read over it, over here, if it's gonna open, yeah, over here, you can read over it if you want. Over your combustion, whatever. Sources of carbon dioxide. It's a product of respiration, decomposition of animals and plants, complete combustion of fuels such as methane, by the reaction between an acid and a carbonate or hydrogen carbonate, and thermal decomposition of metal carbonates. Okay, because when a metal carbonate is heated, a colorless gas is produced. Okay, anyways, you can read over the notes. I'm not here to teach you notes. You can read over them yourself. When hydrogen reacts to oxygen, obviously not. You get H2O there. Question 7. Which of the following statements are true? Photosynthesis is the process by which the plant makes its own food, obviously. Respiration is the process of burning food in cells. You know this, obviously. This is grade 6, grade 7, grade 8 science. Respiration produces carbon dioxide, water, and energy. Yes. Photosynthesis produces glucose and oxygen. I'm going to write this down for you. Photosynthesis, okay, from the bio nerds who know this, it's the change of carbon dioxide plus water to produce, in the presence of sunlight, energy and chlorophyll, to produce glucose C6H12O6 and oxygen gas. This is balanced by doing this. Okay, this means it's balanced. Okay, this is photosynthesis. Respiration is the other way around. Okay, the respiration is the other way around. Okay, it goes 6 oxygen plus C6H12O6 to produce 6CO2 plus 6H2O. Okay. Respiration produces carbon dioxide, water, and energy. Yes, carbon dioxide, water, and obviously you guys know respiration is how we get energy. If you want me to write respiration, it's gonna be 6O2 plus C6H12O6 to produce 6CO2 plus 6H2O, right? Plus ATP, or not ATP. ATP is the bio term for energy. You could say energy. Okay. Photosynthesis produces glucose and oxygen. Yes, I mean, we know this. Photosynthesis process of burning food. No. These questions are very easy. I'm going to go a bit faster. Which of the following is general? Okay. Alkanes, alkenes, ما بعرف شو. I'm going to show you the table. You memorize. Okay. Over here. Whoa. No, I don't want this. They only didn't put it somewhere. Here. This is what I care about. Okay. The formula of these five, this is what we need to know. Okay. Okay. Alkane is CnH2n plus 2. Alkene is CnH2n. Alcohol is CnH2n plus 1, OH. Acid is CnH2n plus 1, COOH. Memorize this whatever you want, but you need to know this, okay? Alkane, 2n plus 2. Alkene, it's just 2n. Alcohol, it's 2n plus 1, but OH, okay? Acids is 2n plus 1, COOH. So, alkanes, what is it? CN, H2n plus 2. Give the molecular formula of an alkane having 2 carbons. So substitute N as 2. So you're going to get C2, H, 2 times 2 plus 2 is 6, right? Easy. Question 9. Locate the correct physical properties of metals. You guys know metals are good conductors. Are they brittle? No. Are they brittle or malleable and ductile? Obviously malleable and ductile. Brittle, yani they break easily. High melting points or no melting points? Obviously high melting points. Question 10. Select the pictures that show a network solid. Of course, it's diamond and graphite, not gold and brass. Any carbon-containing compound and silicon dioxide. Not any carbon-containing compound. It was diamond, graphite, Buckminster fullerene, and it was silicon dioxide. A giant structure that has particular pattern of covalently bond atoms is called a network solid. Inta, when you see giant structure, it's network solid. Okay? Question 12. Something and something have metallic bonding. Obviously, you have to choose the metal from the choices. Obviously, sodium is a metal and potassium is a metal because they're on the left side of the periodic table. Metals are, okay. Metals are something agents that have the tendency to what electron? Obviously lose. Okay? Since you're losing electrons, you're called a reducing agent. Okay? That's memorized. خلاص. It was from the redox chapter, if you remember. Question 14. Metals are something and something. Obviously, they're not insulators and they're not volatile, because volatile means it's a liquid. Metals are lustrous, so they're shiny, and malleable. Malleable means they can be made sharp and cut and whatever. Metals have something electrical conductivity, obviously high, and something thermal conductivity, also high, right? They are good conductors. Solids that do not conduct electricity and have high melting points are what? Ionic solids. See how we said ionic solids, right? If we said aqueous ionic solutions, then it would conduct electricity, but solid ionic compounds do not. Question 16. Consider the following compounds: CH4, C2H6, and C3H8. Okay, they have the same general molecular formula. They undergo substitution reactions, and they have similar methods of preparations. What are these compounds called? Members of a homologous series. These families, alkane, alkene, alcohol, acids, are called families. And in other words, if you're part of alkane, if two elements are part of, two compounds are part of alkane, then they're part of a homologous series. Basically, homologous series, it's a family of similar compounds with similar chemical properties due to the presence of the same functional group. Okay? For alkane, there's no functional group. For alkene, the functional group is double carbon bond. Okay? For alcohol, it's this OH. Okay, it looks like this. For acids, it's COOH. That's the functional group. Okay, you need to know these members of the same homologous series. This came in the written part for grade 11 last year. They have the same general formula. They have similar chemical properties. They have the same functional group. They differ from one before and the other in the series by only CH2 unit. So, alkane, C, if N was 1, then H would be 3. No, true 3. It would be 4, right? If you add another carbon, it's going to add H2. So every time you add one carbon, adds H2. That's what it means, okay? They show a trend in physical properties. For example, melting point and boiling point generally increase with increasing carbon chain length. Okay? These, you need to memorize them. Homologous series, okay? Why are they, if they have, when you see, these are by the way, the properties that we just read. So what do these show? They show that they're called a homologous series, that they're part of the same family. Something is an example of a hydrocarbon, obviously C6H6. The rest probably might have oxygen, might have, I don't know, sodium or whatever. Diamond and silica form giant 3D structures. What are they called? Obviously network solids. What are the type of forces that hold atoms together in diamond and silicon? They're strong, what? Covalent bonds, right? The electrons in these giant structures, are they delocalized or localized? Do diamond and silica conduct electricity? No, they don't, right? So they are localized. Question 19. In a simple model of metallic bonding, a metal is pictured as arrays of cations in a sea of delocalized what? Valence electrons. This is something you memorize. مثل ما هي. I'm not gonna tell you, explain. Memorize. They're cations, obviously, because they become positively charged. The metals, they lose electrons. And what are they surrounded by? Delocalized what? Valence electrons. Pentane has the following structural formula. Select the isomers for pentane. Okay. I'm not going to go deep into isomers and drawing structures and naming and whatever, because that's not really, no, it's not time for it. Okay, you need to know that when you write formulas, you can have empirical formula, the simplest formula, the molecular formula, right? You can have, what's new now is the structural formula, which is how they're arranged. Okay, when the structural formula is basically how it looks, but without writing the bonds. The displayed formula is you actually drawing it, and what we call the skeletal formula. Skeletal formula, you remove. It looks weird, but you remove the carbons. You remove all the carbons. Just forget about skeletal formula for now. The way they drew the skeletal formula for this is basically you remove the carbons and you just consider it one line, okay? And over here you remove the carbon, you consider it one line. And since there's the rest of the things that are present are all bounded to carbon, you remove them all. You don't consider them. Okay, so it just looks like this. It looks like this. OH. That's it. And you don't write this. You write like this. Anyways, forget skeletal formula, it's not that deep. But we have something called isomers. Okay, there's somewhere over isomers. Okay, structural isomers. An isomer is any organic compound having the same molecular formula, but they just look different. So when I say what are the isomers here, that means they're the ones that have the same formula but different structure. So let's see, what's the formula of this? We have 1, 2, 3, 4, 5. It's 5 carbons, so C5. Count the hydrogens. 7, 9, 11, 14. 2n plus, no, it should be 12. 5, 7, 9, 12, yeah, it should be 12. C5H12. Right, so we need to see which one also is C5H12. Let's start here. We have 5 carbons, so C5. Let's count hydrogens. 3 plus 1, 4, 4 plus 2, 6, 6 plus 3, 9, 9 plus 3, 12. So this is also C5H12. So without even looking at the structure, I click it, okay? Here, 5 carbons come in, but if you count the hydrogens, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, it's 12, but why is this wrong? Okay, yeah. These all, I just realized, these all are C5H12. You're gonna see, didn't you say it's when it looks different, but same formula? Yes. But here they look the same. You're gonna say, it's obviously not the same. Look. When is it considered an isomer? If it has one branch. This has one branch, because you can either go down or continue going. When does it not have one branch? If you can complete the whole molecule with one line. Can I complete the whole molecule here with one line? No, I have to go down. But if I don't choose to go down, I can continue going straight. But is the molecule complete? No. Over here, I can complete with one line. Down, right, up. See, I just use one stroke of the line. But here, I can't use one stroke. I'm going to have to use 2 strokes. Here, I can use one stroke. Come down, take a right, go down. That's one stroke, so it's one line. So the structure is the same. There's still no branches. The moment you introduce a branch, that's when you're finally considered an isomer. Over here, I'm going to have to 1, 2. You see how I need 2 strokes? Here I need 1, 2. You see how I needed 2 strokes? Okay. So that means these two have branches. That means when you finally introduce a branch, that means khalas, you change your structure. But here, I'm just rearranging it. I'm just putting this guy down here, or taking this guy up here, this guy up here. But it looks the same, technically. But here, they don't look the same because you actually played with the arrangement. You've made a branch, and that actually changes hatta the name of the molecule. Okay? Question 21. We're going to do naming and stuff later. Okay? And formulas. The something is due to the special way in which delocalized electrons can absorb and re-emit energy, light energy. When you think light energy, any shiny, any luster. The conductivity electrons. Anytime you see electrons, conductivity. The thermal conductivity is due to the fact under temperature. Anytime you think temperature, you think thermal conductivity. The something is due to non-directional bonds, malleability. Non-directional bonds basically means the bonds don't depend on the direction. It could be on the right, could be on the left. So that's why malleability basically means you can hammer it and change its structure, change the way it looks, bend it into weird shapes. So obviously that's because of non-directional bonds. Question 22. Diamond and graphite are 2 solids composed of only carbon, arranged in different structures. What are they called? Allotropes, right? Why are they not isomers? Because it's not organic compounds. Question 23. Obviously, which is which? This is diamond, this is graphite. Graphite is the one that's connected by van der Waals forces. Okay, they're connecting whatever layers. Question 24. Oh, by the way, graphite is a triangle structure in case they ask it. Okay, because you have each one's connected to 1, 2, 3, and when you connect these endpoints, you get a triangle. Okay, in case they ask it. And diamond and silicon dioxide are tetrahedrals, like I explained previously. Okay, which one's which? Furnace lining electrodes, lubricant paints, pencils, obviously graphite. Yeah, electrodes also because it doesn't react. Jewelry, glass cutters, rock borers, obviously diamond. And this is, I think my brother in grade 6 can answer this. What happens when a small amount of carbon dioxide gas is passed through clear lime water? Obviously, lime water turns cloudy in the presence of carbon dioxide. But what happens when excess carbon dioxide is passed? When you leave it for too long or you add too much carbon dioxide, actually it becomes clear again. The turbidity disappears. What is the formula of silicon oxide? You know, it's SiO2, right? It was actually Si. Just memorize it, SiO2. I'm not gonna say why, because in network solid it's not fixed. Carbon dioxide is obviously CO2. So they're saying silicon oxide and carbon dioxide have similar formulae, but very different types of structures. We know that giant structure, which one's the giant one, is a network solid, and you guys know silicon dioxide forms a network solid. But carbon dioxide is just a gas, it's a molecular gas, so a simple molecular structure is carbon dioxide. What are common properties between diamond and silicon dioxide? They both have tetrahedral structure. They have no free electrons. They are non-conductors. They have weak covalent bonds. No, because silicon dioxide isn't weak. They are good conductors. No, obviously not, because they don't have any electrons free. So this tetrahedral structure, carbon dioxide looks like, how can I say this? I don't know how to draw it, صراحة, but let me show an image. Why I'm a bit confused is because I know that CO2 is linear. I don't know how they put tetrahedral. It's kind of weird. If you do know why, please put in the comments. But I think this one is wrong. Okay, I think tetrahedral is wrong. Anyways, thank you so much for watching and good luck in your exam.